So we're going to wrap up our unit on neuroscience and behavior by talking about the top of the nervous system, and that is the brain. And I have some pictures here to kind of get you all excited about what we're going to be learning about all week. Here's a freshly removed brain in all of its glory. Here's a picture of a psychologist removing parts of the brain so that they can study it. And so here's our map for this video today. We're not going to start learning about parts just yet. We're going to learn about parts tomorrow. The goal for today, though, is you're going to learn about different ways that psychologists study the brain. So there are three main ways that they study them. They can study them through clinical observation, manipulation of specific brain parts, and then recording through various imaging techniques. So this is kind of the map that you'll want to copy down for your notes. So first we're going to take a look at the oldest way of studying the brain, and that is through clinical observation of accidents or injuries that people have experienced. So hundreds of years ago they didn't have the fancy techniques that we do today to be able to scan the brain and to see what's going on. So they just were only able to observe when people had certain injuries happen or accidents. So the most famous one that you need to remember is Phineas Gage. And this is a picture of Phineas on the left, and I think we talked about him briefly at the beginning of the year. But Phineas was a railroad worker, and he was in charge of blowing up parts of hillsides so that they could make a railroad on the hillside. And so one day he was using this rod that he's holding to pack in explosive powder into a hole so he could blow it up, and it accidentally exploded, and this rod went through his head, as you can see in this picture here. And prior to this accident, Phineas was a super nice guy. He was a leader on the railroad crew. But after this accident, it changed his life, and not just the fact that he survived, but it changed his personality after it. So if you take a look at this picture on the left here, we know now that here is your limbic system, the center of your brain. Your limbic system is what controls your emotions. This is where your amygdala is. So highly emotional memories, the flashbulb memories are stored here. Any emotion you feel is here. Here is your frontal lobes, and your frontal lobes are your decision-making part of your brain. So you could feel really sad and want to bawl your eyes out and cry, but your frontal lobes are telling you, oh no, I'm surrounded by 1,000 people, I don't want to cry right now. Or you could be feeling really mad and want to go off on someone, but your frontal lobes are the ones that make the decision and say, no, this isn't a good time. So now when that rod came through Phineas's head, it severed the connection between the limbic system and the frontal lobes, and so he was then unable basically to control his emotions anymore. So he turned from this guy who was super nice all the time, a good leader, really in control of how he acted, to someone who acted like a 5-year-old all the time, because he no longer had that physical connection between his limbic system and his frontal lobes to be able to control himself. And so just through this observation of his injury, scientists at that time were able to kind of guess the different functions of the different parts of the brain. They still have his tamponing rod, this is the rod that went through his head, in a museum that they have for Phineas, so you could go see it if you're in that area. But I do have, if you're interested in seeing like a recreation of the accident, I have a couple videos linked on Schoology underneath this one that you can watch. They're kind of corny, but they show basically what happened in his accident. A newer way of studying the brain, but still older, is through manipulation. And there are two ways that you can manipulate to study the brain. You can lesion it or you can stimulate it. So lesioning is when you remove part of the brain, then to see what happens with someone's function after they remove part of that brain. So now when we lesion, we usually lesion with animals. You don't want to obviously experiment with people in that way. So they'll go through different animals and they'll remove parts of the brain to see how that animal responds after more. But lesioning has actually showed us a lot. Most of the time when they lesion now, the big research topics are through aggression. They're trying to figure out how can they maybe make people less aggressive if they take out part of their temporal lobes or part of their amygdala. And so I don't know if you guys are familiar with rhesus monkeys, but they're the most aggressive monkey in the world, and they actually took out part of their temporal lobe, which is on the sides of your head, right above your ears, which is closely connected to your amygdala. And when they removed those, then they learned that this is what caused those monkeys to be aggressive. And so when you take off parts of the brain, then you kind of can deduce what their function is. So that's lesioning. And then the second way that you can manipulate the brain is through stimulating. So rather than removing part of the brain, you send in electrodes into the brain to activate certain parts that may not be active to see what happens. And so I have a video on Schoology as well under the Phineas Gage ones where you can see a man who has Parkinson's disease, which we learned is related to dopamine function. And so he's playing his violin while he's in surgery. So he's awake. They have, his head screwed in so he can't move it. And he's, his violin stick is bouncing because of his Parkinson's. But when they stimulate the part of the brain that is not functioning correctly because of his Parkinson's, you can actually see he goes right into a smooth motion with the violin. It's really cool. Unfortunately, they can't all do that for all the Parkinson's patients. They have put in these little permanent electrodes for some epileptic patients and some Parkinson's patients, but not everybody's able to take full advantage of it. Other things that they've done with stimulation that's interesting is, like, I think I mentioned this at the beginning of the unit too, but you can stimulate the amygdala in a cat and make it fearful of a mouse. So you have full control over people or animals if you stimulate different parts of their brain. So lesioning and stimulating are the two ways to manipulate it, and check out that video if you want to see what it looks like on a person. The newest way of studying the brain is through technological recording of images. So we're going to go through these 4 recording mechanisms now. So the first one is called an electroencephalogram, which is also an EEG. So some of you may have had EEGs before. And an EEG's job is not to show a picture of the brain, but to show a picture of the brain waves. So we learned that when neurons communicate, it's all electric signals. And so those energy waves going through your brain can be picked up by this EEG machine, and we can see if there are abnormal functioning in your brain waves. So when you go to get an EEG scan, you wear a special, it almost looks like a swim cap that has holes in it, and they put this jelly on your head to be able to stick the electrodes to it. So they're not actually sticking anything inside of your head, it's all on the surface. And then you get this report out, which shows your brain waves. Most of the time when people get EEGs, it's either because epilepsy is suspected. So epilepsy is when you have seizures and you have electrical storms in your head from the neurons not functioning well, or used in sleep research. So when we talk about sleep later in the semester, we're going to learn that there are very distinct brain waves in the different stages of sleep. And so if someone has sleep apnea or has a sleep disorder, it's helpful to be able to see what part of the sleep stages that they're having issues with. And so, like I said, we'll get to more of this later in the semester, but an EEG scan is really helpful for showing that. The second brain scan is called a computerized axial tomography, or a CAT scan, which some of you may have had done before as well. And a CAT scan is going to show you a picture of the brain, unlike the EEG scan. And a CAT scan is basically just a big X-ray of the brain. So make sure you have that written down as a distinguishing factor between CAT scans and the other scans. It's an X-ray of the outermost structure of the brain, and it's really good for showing structural abnormalities. So if you think you might have a tumor or a blood clot or something like that, a CAT scan is going to be the scan that will show that. This is a picture here, like if you look here, you can see a tumor, and actually the scan's flipped when you get a scan. So this is a tumor in the left frontal lobe. And so CAT scan is pretty basic. It's just a big X-ray of the brain that shows you structure. It does not show you soft tissue or deeper structures within the brain, just kind of those outermost layers. The third brain scan is called magnetic resonance imaging, or an MRI, which some of you may have had before as well. You can get an MRI on any part of your body, but an MRI in the brain is different from a CAT scan because rather than having it be an X-ray, it's actually using a magnet, and it knocks the electrons off, and so you're able to get a deeper picture of the brain, a more detailed image, and you can actually zoom into the deepest parts of the brain. So it's really cool if you've ever seen an MRI results before. They start on the outside of your brain. You can almost zoom in all the way on the inside, and so you're going to get pictures that look like this, which a CAT scan is never going to be able to show you stuff like this, or even detailed pictures like this. So a CAT scan might be an MRI might be something that you use for a deeper tumor that you can't see just from the outside. It might also be used if you're going to be putting electrodes into someone's brain. It's going to show you more detailed pictures so they know exactly where those electrodes are at different parts of the brain. The fourth scan is called a positron emission tomography, which is also called a PET scan. And this scan is pretty cool. So the CAT scan and the MRI don't really tell you anything about the brain's function. They tell you if there's something structurally off with it. But a PET scan is going to tell you if parts of the brain are functioning incorrectly. So what happens when you get a PET scan is you actually ingest some radioactive glucose, or you have radioactive glucose injected into your body. And we know that glucose is just another word for sugar, but it's radioactive, so that when we do the scan, scan, we can see what's happening to it. So when your brain, like let's say you are speaking, okay, then there's going to be a certain part of your brain that is active when you are speaking. Because you are speaking and it's active, it's going to be consuming more sugar for energy than if it was not active. And so when you get the scan is actually showing which parts of your brain are eating the most sugar. And we can see it because we've made that sugar radioactive. So you're going to get pictures like this. So you can see between, I know it's kind of blurry, but looking, listening, thinking, remembering, and working all have different parts of the brain that light up, different parts of the brain that are consuming amounts of glucose, and so we're able to see function. And so if we think that part of the brain isn't functioning correctly, like after a stroke, for example, we can do a PET scan to see if that part is functioning incorrectly or not, so we know how to help that person heal from it. All right, the last scan is also a magnetic scan. It's called a functional MRI, so an fMRI, and this is probably the most advanced brain scan that we have today. And all an fMRI is, it's a combination of an MRI and a PET scan. So the MRI is going to show the detailed structures of the brain, the inner parts of the brain that we can't see through a CAT scan, but it's also going to show us function just like a PET scan is supposed to show us. So you can see here we have different parts of the brain that are lighting up depending on what that person is doing. So it's measuring that glucose that's being consumed, but it also has the MRI scan behind it. So here's another example of a fMRI image on the left. This was a research study that they did having people anticipate doing math. Actually, they found lit up the same parts of the brain associated with experiencing physical pain. So they had some people that really got anxious about math, and they were able to show that it is in the same parts of your brain as when you experience physical pain. So I just thought that was a kind of an interesting study that they're doing. Okay, so just to recap what we talked about the oldest way of studying the brain, which is clinical observation. Then we talked about manipulation through lesioning and stimulating, and then the 5 brain scans that you need to know about. And so tomorrow, like I said, we're going to start looking at the actual structures of the brain and their functions, and I will see you then.